Hello, Morehouse. This is Mrs. Stanley. Welcome to today's math lesson. Today we're going to be working on Module 6, Lesson 4. So far in our math lessons, we've learned how to generate and organize data in tables. We've learned how to make picture graphs, and we've learned how to make bar graphs. Today, our lesson objective is I can solve 1- and 2-step problems involving graphs. On your own, you will complete Number Gym, Pair and Compare, and Tower of Power in Zern. Together, we will do a Z-Squad guided practice. If you choose not to do Zern, you will be expected to complete your worksheet in your math packet and to send a picture to Mrs. Stanley. Let's get started.
Now we have the scale.
Sorry guys, we're starting from the very beginning.
Hi, I'm Marley.
Hi, I'm Nolan, and I'm in the
Zern Squad.
A scientist measured the number of wing vibrations each second for several animals. Part A. A fly vibrates its wings twice as fast as the hummingbird. How many wing vibrations does a fly have each second? We are learning in this table that some animals vibrate their wings so they can stay in the air.
The scientists measured wing vibrations per second.
A second is a short amount of time, so that means they're vibrating very fast.
They need to vibrate their wings so they can fly or they'll fall.
A fly vibrates its wings twice as fast as the hummingbird. How many wing vibrations does a fly have each second? A fly vibrates its wings 200 times per second because we know that 2 times 100 equals 200. The hummingbird beat its wings 100 times per second. The fly is vibrating its wings twice as fast, so that is 200 times per second.
We need to figure out the number of vibrations per second for the fly. We know the fly vibrates its wings twice as many times as the hummingbird.
To find the last point, we would multiply by 2 to get 200. A fly vibrates its wings 200 times per second.
Now we have all the information, so now we can build the bar graph.
What scale on the bar graph would be best to use for this data? We chose 100 because most of the numbers in our table have 100 in them. So it wouldn't make sense to count by 5s, 10s. 500 is too big, so 100 is the number that makes sense.
The first thing we need to do is label the scale. It doesn't make sense to use 5s or 10s.
So let's label our scale with hundreds.
That works. We'll go up from 0 to 500. I'll start at 0 and then go to 100.
Then 200.
Then 300.
Then 400.
Then 500. Now we have the scales, now we can shade in the bars.
For the honeybee, I shaded in 2 units that would equal 200. And then I knew 250 was in between 200 and 300, so I shaded in 1/2 unit to get 250.
All right, we don't have our notes, so we're just going to kind of talk our way through this. All right, Part C. So Part A was figuring out how many times the fly how many wing vibrations the fly had per second. The second part of this problem, B, was to create a bar graph. And now we're to Part C. So this is 3 parts to the same question. Part C. What is the difference between the animal with the most vibrations and the animal with the least vibrations? In order to find the difference, remember that we are talking about subtraction, right? We want to know what is between the animal with the least vibrations and the animal with the most vibrations. So let's take this one step at a time. Which animal has the most vibrations per second? I know that the answer to this is the mosquito because the bar for mosquito is the tallest. Which animal has the least vibrations per second? You can look at my graph again, and I see the hummingbird has the smallest bar, so I know that it has the least vibrations per second. Now we're going to create an equation to help us solve. Let's talk our way through this since we don't have our notes in front of us today. The mosquito had 500 wing vibrations per second, and the hummingbird had 100 wing vibrations per second. So if we write a subtraction sentence, it would say 500 minus 100 equals 400. I could also count by hundreds by count up, starting after the unit 1 of 100, because I can look and see that 100, or that first unit, is colored in for hummingbird, but it's not, but mosquito is much bigger. So I could count up 100, 200, 300, 400. I think it's easier to just subtract. 500 minus 100 equals 400. The difference is 400 vibrations per second.
When I first look at the bar graph, I know that the mosquito's bar graph is higher than any of the others, which means they're flapping their wings more quickly.
The mosquito is the fastest and the hummingbird is the slowest. The problem is asking us to subtract how fast the hummingbird vibrates its wings from how fast the mosquito vibrates its wings. 500 minus 100 will give us the difference. The difference between the animal with the highest and lowest is 400.
Okay. Part D. So this is another part to this problem. Which animal vibrates its wings twice as fast as a honeybee? So I'm going to look at honeybee, and I see that the honeybee beats its wings 250 times per second. What equation could we write to help us solve this problem? So we want to know what animal vibrates its wings twice as fast as the honeybee. It would be 2 times 250, right? 2 times 250 equals 500. We would just add those two numbers because when we multiply, it's just repeated addition. We're just adding one of the numbers over and over again, as many times as the other number in that multiplication sentence. So 2 times 250, or 250 plus 250, equals 500. The animal that beats its wings 500 wing vibrations per second is the mosquito. So my answer would be the mosquito is twice as fast as the honeybee. So the mosquito vibrates its wings twice as fast as the honeybee.
The question is asking us to find which animal is twice as fast as the honeybee.
The honeybee flaps its wings 250 times per second. I would write 250 plus 250. 250 plus 250 equals 500. The graph shows us the mosquito vibrates its wings 500 times per second. The mosquito vibrates its wings twice as many times as the honeybee.
All right, and we had the same
It makes
answer.
sense because the mosquito's bar looks twice as big as the honeybee's bar.
Great job, guys. So again, you're going to complete the rest of this lesson on Zern, or complete your lesson 4 worksheet and send me a picture of it. I'm very, very proud of you all, and I can't wait to see you all tomorrow.